Thanks everyone for joining me again. What happens when Earth's north and south poles flip? Earth's magnetic poles could start to flip. What happens then? The magnetic field protecting our planet originates deep in the Earth's core but fluctuates in strength over time. As Earth's magnetic shield fails, so do its satellites. First, our communications satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer phone home. And finally, cosmic rays start to bombard every human on Earth. This is a possibility that we may start to face not in the next million years, not in the next 1,000, but in the next 100. If Earth's magnetic field were to decay significantly, it could collapse altogether and flip polarity, changing magnetic north to south and vice versa. The consequences of this process could be dire for our planet. Most worryingly, we may be headed right for this scenario. The geomagnetic field has been decaying for the last 3,000 years, said Dr. Nicolas Thouvenaty from the European Centre for Research and Teaching of Environmental Geosciences, France. If it continues to fall down at this rate, in less than 1 millennium we will be in a critical period. Dr. Thouvenaty is one of the principal investigators on the 5-year EDIFICE project, which has been running since 2014. Together with his colleagues, he has been investigating the history of Earth's magnetic field, including when it has reversed in the past, and when it might again. Cosmic rays. Our planet's magnetic field is predominantly created by the flow of liquid iron inside the core. It has always been a feature of our planet, but it has flipped in polarity repeatedly throughout Earth's history. Each time it flips, up to 100 times in the past 20 million years, while the reversal can take about 1,000 years to complete, it leaves fossilized magnetization in rocks on Earth. By taking cores or columns of sediments from the seafloor, like a long straw that can extend down up to 300 meters with the help of a drill, we can look back in time and see when these reversals occurred. Dr. Thouvenaty and his team looked at 2 particular forms of elements that allowed them to probe the history of our planet's magnetic field in greater detail. For a polarity reversal to occur, the magnetic field needs to weaken by about 90% to a threshold level. This process can take thousands of years, and during this time, the lack of a protective magnetic shield around our planet allows more cosmic rays, high-energy particles from elsewhere in the universe, to hit us. When this happens, these cosmic rays collide with more and more atoms in our atmosphere, such as nitrogen and oxygen. This produces variants of elements called cosmogenic isotopes, such as carbon-14 and beryllium-10, which fall to the surface. And by studying the quantities of these in cores, we can see when polarity reversals took place. The last reversal occurred between 772,000 and 774,000 years ago. Since then, the field has almost reversed 15 times, called an excursion, dropping in strength significantly but not quite reaching the threshold needed before rising again. This is when we are most at risk as the field decays and then recovers its strength. The last excursion occurred 40,000 years ago, and evidence suggests we are heading in that direction again. The geomagnetic field has been losing 30% of its intensity in the last 3,000 years, said Dr. Thouvenaty. From this value, we predict it will drop to near zero in a few centuries or a millennia. The Earth's magnetic field has been weakening over the South Atlantic, blue region. Today, we can already see the effects of a weakened magnetic field on our satellites in orbit. In the Atlantic Ocean between South America and Africa, there is a vast region of Earth's magnetic field that is about 3 times weaker than the field strength at the poles. This is called the South Atlantic Anomaly, SAA, and it's the focus of the CORSAT project being led by Professor Chris Finlay from the Technical University of Denmark, DTU, near Copenhagen. Using data from multiple satellites, including the European Space Agency's, ESA, 3 swarm satellites launched in 2013, this project is trying to figure out what is causing the SAA. This is a region where we see that satellites consistently experience electronic failures, said Professor Finlay. And we don't understand where this weak field region is coming from, what's producing it, and how it might change in the future. Scientists first noticed the SAA in the 1950s, and since then it has decreased in strength by a further 6%, as well as moving closer to the west. There hasn't really been any convincing explanation of it, said Professor Finlay, adding that scientists haven't been able to predict how it's going to alter. The CORSAT project is hoping to change all that, using the most detailed data available yet to study the properties of the magnetic field here and how it shifts over time. By probing the SAA, the team are hoping to see what's going on inside Earth's core that might be causing it. One possibility is that there could be a vast anticyclone in the southern portion of Earth's liquid metal outer core, which may be pushing out the magnetic field from the South Atlantic region. Another possibility is that the magnetic field in this region is pointing the wrong way. In effect, there's a mini-polarity reversal taking place. The SAA gives us a direct look at how a weakened magnetic field can affect satellites, as numerous spacecraft have reported electronic malfunctions when flying over this region as they are hit by cosmic rays. But it's unclear at the moment if the SAA has any relation to the Earth's magnetic field flipping in polarity, which is also something to prove. In some simulations you see features like the SAA growing during a pole reversal, he said. It's not necessarily the case, but it wouldn't be a surprise if something like this was involved in a magnetic reversal. A glimpse nevertheless, the SAA just might give us a glimpse of what is to come in the near future. If trends continue, our planet's magnetic field could reverse again in 1 or 2 millennia. Prior to that, the field may continue to weaken, and within a century we could be faced with serious problems. The decrease in geomagnetic field is much more important and dramatic than the reversal, said Dr. Thauvenei. It is very important to understand if the present field will decay to zero in the next century, because we will have to prepare. Thanks for watching.
Did you know that Earth has 2 North Poles? There's the geographic North Pole, which never changes, and there's the magnetic North Pole, which is always on the move. And right now it's moving faster than usual. Over the last 150 years, the magnetic North Pole has casually wandered 685 miles across northern Canada. But right now, it's racing 25 miles a year to the northwest. This could be a sign that we're about to experience something humans have never witnessed before: a magnetic polar flip. And when this happens, it could affect much more than just your compass.
Right now on the surface of the planet, it looks like it's just a bar magnet, right? Our compasses are just pointing toward one pole at a time, because there's a dominant 2-pole dipole system.
But sometimes, Earth doesn't always just have a single magnetic north and south pole. Evidence suggests that for hundreds to thousands of years at a time, our planet has had 4, 6, and even 8 poles at a time. This is what has happened when the magnetic poles flipped in the past. And when it happens again, it won't be good news for humans. Now you might think that 8 poles must be better than 2, but the reality is that multiple magnetic fields would fight each other. This could weaken Earth's protective magnetic field by up to 90% during a polar flip. Earth's magnetic field is what shields us from harmful space radiation, which can damage cells, cause cancer, and fry electronic circuits and electrical grids. With a weaker field in place, some scientists think this could expose planes to higher levels of radiation, making flights less safe. This could also disrupt the internal compass in many animals, which use the magnetic field for navigation. Even more extreme, it could make certain places on the planet too dangerous to live. But what exactly will take place on the surface is less clear than what will undoubtedly happen in space. Satellites and crewed space missions will need extra shielding that we'll have to provide ourselves. Without it, intense cosmic and solar radiation will fry circuit boards and increase the risk of cancer in astronauts. Our modern way of life could cease to exist. We know this because we're already seeing a glimpse of this in an area called the South Atlantic Anomaly. Turns out, the direction of a portion of the magnetic field deep beneath this area has already flipped. And scientists say that's one reason why the field has been steadily weakening since 1840. As a result, the Hubble Space Telescope and other satellites often shut down their sensitive electronics as they pass over the area. And astronauts on the International Space Station report seeing a higher number of bright flashes of light in their vision, thought to be caused by high-energy cosmic rays that the weaker field can't hold back. Since experts started measuring the anomaly a few decades ago, it has grown in size and now covers a fifth of Earth's surface, with no signs of shrinking anytime soon. This is so extreme that it could be a sign we're on the brink of a polar flip, or we may already be in the midst of one. But scientists remain skeptical, mainly because
the last thing the poles reversed was 780,000 years ago. So it's not, we don't have an oral record of.
Turns out 780,000 years is over double the time that Earth usually takes between flips.
Since the last mass extinction, there have been reversals roughly every 300,000 years.
So what gives? Well, scientists haven't figured it out yet. It's unnerving to think that our modern way of life, banking, the stock exchange, missile tracking, GPS, relies on the outcome of something we can neither predict nor control. One study went so far as to estimate that a single giant solar storm today could cost the US up to $41.5 billion a day in damages. And that's with the Earth's magnetic field at its current strength. It's frightening to even imagine the devastation a storm would bring to an Earth with a magnetic field only 10% as strong as it is now. We may not be able to stop a polar flip, but we can at least start to take measures to minimize the damage. The first step? Figure out what's going on with this wacky field. On the hunt are the European Space Agency's swarm satellites that are currently collecting the most precise data on the strength of Earth's magnetic field. Right now, they could be our greatest hope for solving this riddle.